Hello, my name is Akash Arora, and I'm a developer here at Radiant Zemax. Today, I'd like to talk to you about the Zemax Illumination Wizard, a set of features that is available in Zemax 13. If you've ever spent time designing or optimizing non-sequential optical systems, you'll know that it can be time-consuming to create non-sequential Merrit functions. Some are simply too complex to create manually. Typically, non-sequential Merrit functions share some common aspects. Detectors are cleared, rays are traced, and data of interest is computed. Due to these common aspects, creation of non-sequential Merrit functions is a good candidate for automation. Indeed, this is the purpose of the Illumination Wizard. The first feature of the Illumination Wizard that we'll look at is the non-sequential Merrit function tool. It is used to dynamically create common Merrit functions. We can target things like uniformity, maximum flux, color, and many others. Let's take a look at how this works. In this optical system, we've defined a curved light pipe, a source launching rays in, and a detector collecting rays. Typically in such a system, we would target things like maximum efficiency and maximum uniformity. Rather than do this by hand, let's let the Illumination Wizard do it for us. The Illumination Wizard can be found in the Merrit function editor under the Design menu. I'll select Non-Sequential Merrit function. You'll note that the settings are divided into common categories based upon the common aspects of non-sequential Merrit functions. We clear detectors, we trace rays, and then we compute criterion of interest. In this case, I'm only going to change a couple of settings. I'm going to ignore errors during ray tracing, and we're going to target maximum spatial uniformity. I'll go ahead and click Apply, and notice what happens. The dialog stays open so that I can define additional criterion if I choose to do so, and the operands based on the previously defined settings are added to the Merrit function. The second target we wanted to achieve was maximum efficiency. We'll do this by selecting total flux, and we'll set the target equal to 1 watt, which is the amount of power in our source. This time I'll click OK. The dialog is dismissed and the requisite operands are added. We now have a compound Merrit function that clears detectors, traces rays, and computes criterion of interest. From this point, optimization proceeds as normal. We can define variables and execute a local or a global optimization. This is only one aspect of the Illumination Wizard. Let's take a look at the second aspect. Sometimes targeting things like uniformity or efficiency is too simplistic for what we're trying to achieve. The Bitmap Merrit function tool allows us to target any complex flux and color distribution that we can define in an input image. Bitmap, JPEG, and PNG formats are all supported. Let's take a look at how this works. We'll come back to the system we were just looking at. I'll delete all of the operands that we previously added to the Merrit function. In addition, I'm going to set the detector rectangle we were using previously to ignore, and I will set the detector color, which was previously ignored, to be considered. We'll do this to illustrate the effect of color targets in the Merrit function. I'll go to the Design menu of the Merrit function editor and select NSC Bitmap Merrit function. You'll notice that many of the settings are the same, except the target settings differ slightly. Here we're specifying an input file that represents the flux and color distribution that we're seeking. I'm going to select the color detector, and I've created a test pattern that we're going to target here. Note that the preview that is shown is not simply an image of the input file, but that input image resampled across our detector. It is not necessary for the detector to have the same pixelation as the input image. If we do have different pixelation values, we can select Resample Detector, in which case the number of pixels on the detector will be changed to match the input image. We also have the ability to select or not color targets. The preview image also shows this effect. In this case, we will select color targets, and we'll go ahead and click OK. Zemax quickly adds the necessary operands to clear detectors, trace rays, and then target the values at each individual pixel. You'll notice that we have one operand to target the total flux. This gives us the absolute amount of power on the detector. The rest of the operands target the relative flux at each pixel, and we're targeting the X, Y, Z tristimulus values at each pixel. The targets are chosen by Zemax to match the input image. This is a capability that would have been impossible to do by hand previously for large input images. The capability is now in your hands to do it in an automated way. This has been a look at the Illumination Wizard that's available in Zemax 13. To see this and all new features that are in Zemax 13, you can go to our website at www.radiantzemax.com. Thank you for watching.